All right, looks like we're on air. Dr. Rana, thanks again for coming on and being willing to have a conversation. I actually had a interesting. I've been watching some of your debates, and you've mentioned that you and Dr. Ross have been working on a creationist model, a scientific creationist model that can make predictions. How has that been going?
It's been going well as a whole. I mean, it's um, a lot of people I think misunderstand in effect what we're trying to do with that. Many people think that we're trying to advocate kind of a reform of science, or that we're trying to push our ideas into the scientific arena. It's really more of an approach that helps to present kind of the scientific case for God's existence and the credibility of the scriptures, the Old and the New Testament, in a format that scientists can appreciate and understand, by saying, okay, if this is true, then these are ways that you could go about testing the idea, potentially falsifying it, or affirming it. So it's not meant to be quote unquote a scientific model in that sense, but it's really more of an approach to engage people. And I find that in general, people are intrigued by that idea. And people, particularly that are scientists or scientifically minded, appreciate the idea that we're demonstrating ways in which our ideas can be kind of put in harm's way, so to speak.
Could you move your mic a little bit away from your zipper? It's moving up and down, making a clicking noise.
Oh, sure. I'll just do this. Is that better?
Yeah, thanks. So,
Okay.
what kind of predictions can you make with the creationist model, the scientific creationist model that you're working on?
Well, like the easiest one that I think, people could understand, and this is outside my area of expertise, scientifically speaking, would be the statement in Genesis 1:1 that, in the beginning, God creates the heavens and the earth. And that phrase, heavens and earth, in the original Hebrew, is in reference to the totality of all that exists. And so the idea here in Genesis 1:1 is that that there was a beginning to the totality of all that exists, or there's a beginning to what we would understand today as the universe. And so that would be a prediction. Does the universe show a beginning or not? And of course, that's one of the things that's, provocative about what's happened in astronomy in the last several decades, is that we at least understand that our universe had a beginning, or at least it emerges out of what appears to be a singularity event that you could take as a beginning. Now, of course, people are arguing that there very well could be a multiverse, that our universe is a local universe that's part of a multiverse. And that's, of course, an open scientific question. But we at least know that our local universe, at minimum, looks as if it has a beginning. So that would be an example of a prediction that you could make that then could be used to evaluate biblical ideas. So not only is it addressing issues philosophically, or at least philosophical arguments for God's existence, but also it brings it into a framework where you're evaluating scripture. Another one would be, were Adam and Eve historical individuals, right? That's something that you see in the Genesis 2 creation passage, that there was a male and a female that gave rise to all of humanity, or at least that's one way you would interpret that passage of scripture. So is there a way to test that idea scientifically? Yes or no, right?
Do you think that the model you're working on will be able to make comparable predictions to that of like evolution and chemical engineering and those kinds of things? Like the same amount or the same detail?
Um, yeah, that's a great question. If what you're asking, if I'm not answering with what you asked, please correct me or redirect me. But in many respects, when you look at two scientific theories, the predictions that they make are logical entailments of those ideas, those theories, and that's really what constitutes the predictions. And so two theories that are looking to address the same phenomena may actually make very different predictions from one another. But those predictions don't always necessarily have a one-to-one correspondence. So when it comes to taking like an evolutionary view for the origin and the history of life, there are a set of predictions that flow out of that framework. and there's a different set of predictions that flow out of a creation model framework. And so there doesn't necessarily have to be a one-to-one correspondence. Now, in terms of the number or the details or how detailed those predictions can be, that really is a great question, and I think a fair question. And I think there are some instances where you can make some fairly detailed predictions, other instances where you can. I think there's other instances where where if you're relying on scripture, you could kind of make broad brush predictions, and then you might then, of those with respect to a individual prediction, there might be several alternative models that would arise from that each would have its own separate prediction. So, for example, like when it comes to the origin of life, one prediction would be that if there was a mind behind life's beginning, that life, at least at a molecular level, should have the appearance of design. That's not a prediction that would flow specifically out of scripture, but it is a reasonable prediction if you're operating in a creation model. Does that make sense?
Yeah, definitely. So, but evolution makes like really precise predictions where it says like we'll be able to find this kind of fossil, which we presume to be a transitional fossil in this exact layer, in this exact region, like Tiktaalik and Archaeopteryx and Probringnacthus and all these other different transitional fossils, what they predicted
Yeah.
with high levels of accuracy. Can your creationist model kind of match those really detailed kind of predictions?
I think in some places it might be able to. In other places it may not be able to. And it is true that there are places where the evolutionary paradigm, does make detailed predictions. There's other places where it doesn't make predictions at all. And that's not meant to be a criticism against that model. It's just inherent in the nature of the model and what that model is trying to do, by way of phenomena. But in
Well, can you
some
give me an
respects,
example of one of those things where it doesn't make predictions?
well, I mean, for example, some people would say that the evolutionary process is historically contingent, right? Which means that it's predicated on a sequence of chance events, that each event has ramifications for what's going to happen next. And the idea is that if you rewound the tape of life and replayed the evolutionary process, the outcome would be different every time because of that sequence of chance events that constitutes the evolutionary pathway. So in other words, in a general sense, evolution would not be repeatable. So because of that, you can't really predict in the future what organisms are going to necessarily evolve, right? So that would be a place where the evolutionary paradigm doesn't make a prediction, right? And so you can't. And so, for example, I've seen some Christian apologists who use scientific arguments make the argument that the compound that's produced in plants, lignin, I think there's not enzymes in nature that would digest it. And of course, if a bacteria would evolve that capacity to digest lignin, it would just go to town. It would take over the earth, right? And so I've seen people criticize the evolutionary model, saying that if this was really true, we'd expect to see these lignin digesting microorganisms, right? And so, but that really is, I think, misrepresenting the evolutionary paradigm because it doesn't make that prediction, and it would never make that prediction because of the historically contingent nature. But that's an example of where evolution just doesn't make predictions about what's going to happen in the future, right? So that would just be an example off the top of my head. Yeah. So that would be one example.
Well, that makes sense, yeah, because evolution is random, so we can't predict what advantages will be mutated if it's true.
Right. Right.
Well, so the reason I wanted to talk to you today was I wanted to ask, why do you think that like the complexity of life and the abiogenesis, the origin of life, why is that indicative of a designer as opposed to just unknown natural processes that we haven't discovered yet?
Yeah. Well, a little bit about how I came to faith in Christ. It happened when I was a graduate student. I was an agnostic as an undergraduate. I didn't know if God existed or not, and really had very little regard whether God existed or not. That wasn't really important to me. And I wholeheartedly embraced an evolutionary framework for science. It strongly felt like the origin and the design and the history of life could be explained through evolutionary mechanisms, and held that view going into graduate school. And what intrigued me as a graduate student was just how elegant and sophisticated biochemical systems are. To me, there was this ingenuity in terms of the way that they operated, and and when I explored, how does the origin of life work? What are the details for the origin of life? I found that to me, those models seem to be really coming up short in a significant way in terms of accounting for that. And so, to me, those two observations, one in which you have biochemical systems that had the signatures of design or the appearance of design, plus the inability to explain that design, to me indicated that there must be a mind. It's interesting, about the time that I was in graduate school, there were two popular science books that were everybody was reading, and they both were by Francis Crick, the Nobel laureate who discovered the structure of DNA. One is called What Mad Pursuit, which is a fascinating account of his perspective on the discovery of the DNA double helix. And he concludes the book by saying, biologists must constantly keep in mind that what they see was not designed, but rather evolved. And I think the implication of that was that, look, the first reaction you have when you look at these systems is they appear to be designed. And of course, he argued that even though that's the intuition you have, you need to be disciplined enough to look for evolutionary explanations. But he wrote another book called Life Itself, which is on the origin of life question. And he basically talked about the fact that the origin of life appears to be a miracle at the, so many are the things that need to happen to get life going. And, so here, in a sense, Crick, not that I would compare myself to Francis Crick in any sense, but here, Francis Crick, in a sense, was articulating the same things that I was articulating as a graduate student, which was things look like they're designed and we don't have an explanation for the origin of life. He was, a lifelong atheist, deeply committed to the atheistic, to an atheistic framework. And I saw this as evidence for a designer. And so to me, I think it's completely reasonable to say if things look like they're designed and the quote unquote blind watchmaker mechanisms can't account for that it's not an unreasonable thing to think that there's a creator. And of course, that then leads to other questions like, who is that creator, and do I relate to that creator, and so how? So that, in a nutshell, that would be, kind of the argument. And, I've spent the last 3 decades repeatedly revisiting those conclusions that I drew. I am a scientist at heart, and I continue to test ideas. And I don't see there's a lot of interesting ideas that have emerged in origin of life research over the last 30 years, but none of them contribute substantially to an understanding how life originates. I think we still are basically at very near ground zero with respect to the origin of life. And if anything, the appearance of design in biochemical systems to me seems to be even more exquisite as we've developed advances in biochemical methodologies. So I think the case is actually stronger today than it was when 30 years ago.
From my perspective, that sounds a lot like what Newton said about the concentric orbits of the planets, where he said that the most beautiful system of the sun, planets, and cosmos could only proceed from the counsel and dominion of an intelligent and powerful being or something like that. And he thought that it was so complicated, he couldn't do the math, he couldn't figure it out. And so he just said, well, it's probably done by a being because it must be finely tuned, essentially. Yeah. But then 200 years later, Laplace came along and said, well, nope, I can do this without a God. And I just figured out this new way to analyze the math that that Newton didn't know about. So couldn't the origin of life and the complexity of the cell be a similar kind of thing, where it seems really complicated because we don't have a complete picture, and that we could make discoveries in the future that could actually explain why or a simpler way that it could come about with a different natural process we don't know about, or a different environment that the earlier might have had that we just haven't discovered yet. Like, aren't those possibilities? Why are we ruling those out and going to a designer?
Yeah, well, I mean, that's a fair question. And I mean, I think somebody would be completely reasonable to adopt that stance, right? I wouldn't dispute, or I wouldn't I wouldn't criticize somebody for adopting that stance. And in fact, as you're pointing out in your example, the history of science is filled full of examples where what we had no understanding whatsoever, and there were key discoveries that were made that suddenly unlocked explanations that seemed to be inaccessible, even a few years prior to that key discovery. So that's always very much a possibility when it comes to the origin of life and in the design of life. But in a sense, it's also possible that we won't make those key discoveries either. And for example, when it comes to the origin of life question, it's interesting because Stanley Miller did his famous spark discharge experiment, or at least published the results of that in 1953. I think it was published first in Science. And that was the same year. I think he published his paper in May. And if I'm not mistaken, I think it was April of 1953 in Nature that Watson and Crick and Maurice Wilkins published the structure of the DNA double helix. And so in a 70-year span of time, we've had the molecular biology revolution and now the genomics revolution. And I think in the process, the trend line is that we're seeing, in my opinion, more and more evidence for design as a result of these revolutions. And yet here we are, the same duration of time, roughly 60 some years from when Miller did his experiment, and we've really made no significant progress, on the origin of life. So in other words, the trend lines really seem as if they support the idea of design and support the idea that we don't really have an explanation for the origin of life. And you could argue that, in a sense, to appeal to future scientific advances to resolve a conundrum now is like an informal fallacy, right? The ad futurus fallacy. But it's not, I don't think that would be completely fair to bring that or to make that argument, because again, there is a history where scientific advance does make discoveries that were unimaginable. So, I mean, it's a fair counter to my argument, I think. But at least at this point in time, given the trends lines that we see, if we have to make a decision based on what we see, I think it's not unreasonable to make a decision for a creator.
So a question, you said that the fact that we haven't made progress is indicative of design, but that seems to be not evidence to support the design conclusion. That's just evidence we haven't found a natural solution yet. Like, for example, evidence of a design conclusion would be like if you theorize a designer and can say, this designer made life in this process and we can reproduce this process in the lab before anybody else does. Now, if you could do that, I would be truly impressed and be like, yep, that's evidence. They probably know what they're talking about. There's probably a designer. But just the fact that natural processes haven't answered this yet doesn't seem to be indicative of design. So how are these things indicative of design?
Yeah, that's again really a real important point that you're raising. And to be clear, and if I through my sloppy communication communicated otherwise, I apologize. I'm not making a God of the gaps argument, or at least I'm trying very hard not to do that. So my argument isn't, well, we can't explain the origin of life, therefore a creator did it. It's really two things at once. And that would be, we can't explain the origin of life currently, but biochemical systems actually have the qualities of what we would expect to see in systems or objects that are the product of design. So in my book, The Cell's Design, I talk about revitalizing the watchmaker argument of William Paley, where Paley, laid out or argued that a watch has certain properties that reflect the work of a watchmaker, and that in the argument is by analogy. And when he looked at biological systems, he saw those same properties, and therefore he concluded that these are the work of a divine watchmaker. And so the term that he used to summarize that ensemble of properties is a contrivance. And so what I do in The Cell's Design is I delineate certain properties that systems that are designed by human beings possess, and point out and then demonstrate that these are the same properties that we see that characterize biochemical systems. And then on top of that, there are also biochemical systems that are in their entirety resemble in an eerie way man-made systems. So I'm making a watchmaker argument where I'm trying to be painstaking in terms of saying here are specific qualities that reflect design, and we see them. And then on top of that, there's another book that I've written that kind of augments the cell's design, and that would be a book called Creating Life in the Lab, where I point out that the attempts on the part of people that are working in synthetic biology who are trying to create artificial cells demonstrates the critical role intelligent agency plays in trying to take molecules and assemble them into chemical supersystems or protocell type systems that begin to assume the properties of life. And so it really is a three-pronged argument that I would be making, where two of those lines of argumentation are positive arguments, where we're saying, look, it takes intelligent agency to create things that look like cells. The cells look like they are designed, and we can apply a formal argument to demonstrate how those properties point to design. And we also see that we don't have an explanation for the origin of life. So I think those three things together do more than just make a God of the gaps argument, but it's an attempt to make a positive argument, really.
Well, can't we say like everything you just said there, I think can be said is just like a verbatim quote of what people originally said about computers. Computers can't do math because they won't be able to understand it, or computers won't be able to beat humans at chess, or computers won't be able to beat humans at Go or Jeopardy, or Einstein about fission, where he said like there's not the slightest indication that we will ever be able to do nuclear energy will ever be obtainable, because it would mean we could split the atom at will. Like it's been said many, many times throughout history about non-horse-drawn carriages and light without fire, and we can't travel past the sound barrier. Like all these things that you've said is very similar to all the things that scientists have said in the past about all of these other instances. I don't see a substantive difference. And the fact that one of the things you said was that all of the attempts to do this in the lab require a great deal of human intervention and fine tuning. But again, I think that is attributable to the fact that we don't really understand it yet. Like originally to do DNA synthesis took a great deal of effort, and professionals in the field in a highly fine-tuned lab manipulating this. But now we can just buy a $30 kit and do it in high school with like aggregase electrophase or whatever it's called, the little blue DNA synthesizer thingy to separate the DNA. So it seems like the reason that human interaction is required at this stage is simply because we don't have a good understanding of it, and it probably won't if we ever discover it. Like Nelson Mandela said, everything seems impossible until it's done.
Yeah, well, and I wouldn't say that creating life in the laboratory is impossible. I actually am of the opinion that we will be able to create artificial cells in the laboratory. But I think the example of the work in synthetic biology is qualitatively different than the examples that you pointed out there. Because even if you could wind up, doing something really easily in the lab, it still would require manipulating the systems in such a way that you get these exacting set of conditions. And so, for example, my training is in membrane and lipid biochemistry and biophysics. And for people that know anything about biochemistry, the cell membrane and the internal membranes inside the cell are made up of phospholipid bilayers, at least to a first approximation. And when you throw phospholipids into water, they spontaneously form bilayer structures. But in actuality, what they form are not single bilayers, which is what you see defining cell membranes, but rather they form these stacks of bilayers, or these onion-like structures, these multilamellar vesicles, or these multilamellar sheets. And it turns out that you can get single bilayers to form, but in a laboratory, but it requires an exacting set of conditions. In fact, a single bilayer phase is a critical phase that requires a precise set of temperature, pressure, and compositional and a composition. And when you hit that exactly right, you'll form a single bilayer spontaneously. And so you might be able to say, well, formation of a single bilayer is really easy. And it is easy once we understand the phenomena, but in order to execute it requires, again, a precise manipulation of conditions where the researcher had to play a key role in orchestrating the conditions in the lab to get that precise set of conditions. And so, to me, I think that shows that intelligent agency is indispensable in that process. as opposed to just saying that we don't quite understand it. Because even if we do understand it, you still have to have intelligent agency to manipulate systems in a non-natural way.
Yeah, for example, Sidney Fox and the Russian researcher Perrin, who do the membrane research on fatty acids and show that they can produce vesicle membranes. But it seems like that's only one of the potential ways that these can form, like the one way we happen to know about, which may only be one of many ways that it can happen. And there may be certain ways that it's far more likely and easier to produce than
Right.
these ways. These are just the ones we've discovered so far. Isn't that right?
Well, I mean, if you're going to get a vesicle, or you're going to get some kind of bilayer structure, you're going to have the phospholipids be produced by some mechanism, or the fatty acids, and they're going to have to dissolve into an aqueous phase, and then they will spontaneously aggregate once they get above the critical micellular concentrations. But like with, people believe that the very first cell membranes were, again, made up of fatty acids, not phospholipids. And those fatty acids will form vesicles, but their natural inclination is to form either spherical structures, micelles, or either spherical micelles or these tubular micelles. And they only form vesicles under very precise sets of conditions, where you have to have pH. You can't have any kind of cationic or anionic materials in the system, and you've got to have the just right lipid compositions in order for these things to form. And so to me, what that's saying is that the likelihood of this happening on the early Earth is extremely remote. And if it did happen to form, that any kind of environmental fluctuations would cause that vesicle to collapse into a non-bilayer phase. And so to me, it's hard to envision how that could happen on the early Earth to support that step in the origin of life. And again, we can do it in a lab, but it requires intelligent agency. So that would really be the crux of my argument. And just as an interesting point, there was an article published just recently. I think it was in Science. Was it in Science Reports or Nature Communications? I'm sorry, I forget the journal, but it was a commentary piece written by an origin of life researcher, and the title of the paper was Prebiotic Chemistry and Human Intervention. And his whole point was, most of the work that's done in prebiotic chemistry today really is successful because human beings are intervening, and we don't account for that when we report the results. And so, he's raising questions about, unless we really truly account for human intervention, it's very hard to argue that what we do in prebiotic chemistry is actually relevant to the origin of life. So it's not just simply me making this argument, but origin of life researchers are realizing that this is really a very important very important problem in prebiotic chemistry, and it's one that isn't recognized. I don't think anybody's engaged in conspiracies or anything like that. It's just not recognized because I think it's so easy to overlook the role of a researcher in origin of life research, and that would again be my argument, is that when we don't overlook the researcher, it's actually an empirical case that intelligent agency is required.
I totally agree, but do you think that the current ways that we've discovered in order to produce membranes, which are very delicate, do you think those are exhaustive, or do you think there can still be other ways that we haven't discovered yet, and probably more efficient ways and easier ways than what we've discovered so far?
That's probably the case. But knowing what I know about membrane biophysics, probably those procedures are going to involve probably some complex chemical instruments that will, through non-equilibrium conditions, kind of force the formation of vesicles. So I can see, for example, you can get vesicles to form very, very easily from multilamellar sheets through repeated freeze-thaw cycles. But those vesicles that form are metastable phases, and they'll collapse. So I could envision, maybe some kind of system where you're forcing a lipid solution through, or a lipid suspension more appropriately, through, some kind of, micro orifice that, under high pressure, that would force the vesicles to form. And it might be a very robust, process. but again, that to me is highlighting the fact that design seems to be, or intelligent agency seems to be a vital part of that process. That what you're doing now is further and further removed from what you'd see on the origin, with respect to the origin of life. So
So if we could find natural processes that kind of replicate that system, would that lower your certainty about this being a design process?
yes, yeah, yeah, yeah.
So it seems like another thing you said earlier was that we haven't made a lot of progress, and it seems like it's become more difficult. But from my understanding, we have made quite a bit of progress. Like, for example, the fact that RNA can be produced on sheets of clay, and that RNA can self-replicate, and that there's maybe the pre-RNA, the PNA molecules, and that we've observed
Right.
algae going from single-celled organisms to multicellular, and all kinds of things. So it seems like we've made quite a bit of progress of doing the little stages along the way, kind of like watching the Wright brothers build a plane one piece at a time. We're seeing the pieces being built, even if we haven't completed the plane yet. So it seems reasonable to conclude that based on the progress, it's going to continue to some point.
Right. Yeah, well, and let me clarify what I mean by that, because I think your point is a fair point. And I mean, there's been a lot of work done, over the last 60 plus years in origin of life research, and I have actually enormous amount of respect for the people that work in that area. I have gone to a number of origin of life conferences just as an attendee, just listening to presentations that have been given and reading posters and things like that, and talking to origin of life researchers. And I really like them. I mean, they're an interesting breed of scientists, where they are very creative. They are willing to tackle one of the hardest scientific problems that is out there, and so the level of ingenuity and creativity that is represented by that community of scientists is very impressive. And and there are a lot of ideas that are brought to the table about how the origin of life might have happened. And you're making reference to, like the RNA world. Uh, and there's three major approaches that I've seen people take to the origin of life. One is the what's called the replicator first approach, which is the RNA world represents. Another is called the metabolism first approach, where people are looking at the formation of autocatalytic cycles that would then morph into kind of protocellular entities. And the third approach is the membrane first scenario. And all three approaches ultimately run into very significant, serious, intractable problems. Uh, so for example, with the RNA world, you mentioned, the assembly of RNA on clay surfaces. And those were considered to be very important experiments in terms of giving impetus to the RNA world hypothesis. But when you look at the details of those experiments, first of all, they're done under chemically pristine conditions. They have to be done in pure water. If you have any ions present in the system, it's going to inhibit the synthesis of RNA on clay surfaces. So you have to have chemically pristine conditions. It's got to be pure water. And in fact, you actually have to take the clay and exchange all of the ions with sodium ions. You have to essentially natriate the clay. You can't have any organic materials around that would likely be present on the early Earth, because they will interfere with the formation of the RNA chain. This is actually called the homopolymer problem that applies to any replicator first scenario. This was identified by Robert Shapiro as essentially a problem that in his mind was so intractable that it ruled out replicator first scenarios. And then you got to use chemically activated building blocks that would most certainly not have existed on the early Earth for the reactions to take place. And the clay, has to be treated, again, as I mentioned, in the just right way. So in other words, what you're looking at is intelligent agency being absolutely critical to affect the assembly of RNA on clay. And what's done in the laboratory only very crudely mimics or simulates what would likely the environment have been like on the early Earth. And so that would just be one example of that. Leslie Orgel wrote a number of really nice papers before he died, critiquing the metabolism first scenarios. And his big problem was that when you have these autocatalytic cycles, you're relying on minerals to, or metal centers in effect, associated with minerals to catalyze the reactions. But the catalytic capability of a mineral center is very limited. And so what has to happen is that you're going to have that after that chemical transformation takes place, you have to have that molecule migrate to another site in order for that the next transformation to happen. And he basically described it as basically if pigs could fly chemistry. And again, with membrane first scenarios, we talked about some of those problems, is that while you can do this in the laboratory, again, translating it to the conditions of the early Earth are really problematic. So, I mean, in a sense, all three approaches have generated an enormous amount of work that's been published in the literature. It's high quality work, to be certain, but it doesn't really get us any closer to understanding the origin of life. Now, there's a new approach that's being advanced by a guy named Nick Lane, which is a bioenergetics first approach, where he's looking at maybe the origin of life taking place in alkaline hydrothermal vents, and they have to be specifically alkaline hydrothermal events. And so I'm just beginning to read about that idea, but his idea is really very interesting. And so I think it merits, a serious consideration, serious evaluation. So this would be an example of where here's another idea that's coming to the forefront that is creative, that is inventive. I'm impressed with the way Nick Lane thinks. And yet I think I don't think this idea has been really put through the rigors yet of testing, but it is an idea that is worth exploring. So to me, if there's a possible way to work around all these problems, maybe Nick Lane has come across it, but my suspicion would be that he hasn't at the end of the day.
Well, how is this different from every other invention of humankind? Because when we first started to discover something, it was always really, really complicated, extremely difficult, took a lot of detailed effort to do. But then after we started to understand it, then it became easier and easier and easier. So it seems the reason that it requires all of this extremely delicate processing is not because it's necessary, but it's just because we don't understand it yet. But because you said that this was different from all the other scientific inventions, but I don't see how it's different because it seems the same to me. They all start off as really complicated like this.
Yeah, I guess the difference would be that at the end of the day, it's very clear that intelligent agency is indispensable. That human intervention at this point looks like it's an absolute requirement to affect the chemistry that you would need for each hypothetical step in the origin of life. So I guess I would just at this point maybe just beg to disagree with you, on that. Is that we probably just see this very differently. I see the intervention as being indispensable, and I don't think it's just simply because it's a really very hard problem or that we don't understand. I think the fact that we do actually understand the chemistry very well is why we're able to actually affect the intervention in such a way to bring about the success that we do see. But again, you can't get away from the central role that the researcher seems to be playing. And again, that to me, the researcher becomes a stand-in for the involvement of a creator.
I tend to agree with what Thomas Edison said, that we only know 1,000,000% of anything. So I would say that that also applies in the case of our current understanding of chemistry and biology, that we only understand 1,000,000% of what there is to understand. And I don't think that based on that very small percentage of what we do know, that it's fair to say that there are intractable problems, because they're only intractable and they're only really big problems based on the current limited knowledge we have. They don't apply to all the stuff we haven't discovered yet, which I would still assume is a majority from my perspective. We don't know the majority of things that there are to know about this. So do you think it's reasonable to say that based off of the limited knowledge we have, that we can say that there are the things that are intractable problems, or just intractable given the very limited knowledge we have?
Yeah, I think you make a valid point there. I think you would say that they would be intractable based on the knowledge that we have available to us today. Now, I might dispute that knowledge is limited, but I mean, in the sense that if we don't know what we don't know, you can't really ascribe a percentage to what we know and relative to what we don't know. but I think, I mean, I think your point is a fair point. And I mean, in a sense, where I think if I could summarize where I think the two of us disagree is that, you know, I think that, you know, based on what we see today, that we have enough evidence to say that it really does look like there's a mind involved. And what you're saying is that you're holding out hope that as we make future scientific discoveries, what appear to be intractable problems are going to resolve themselves in such a way that the case for the creator that I'm making would evaporate. And so that really is essentially where you and I would I think diverge in terms of the conclusions that we would draw. And I wouldn't say that I don't think either conclusion. I don't think either of us are being irrational, I guess, is my point. You know, because you know, unfortunately, in life we have no choice but to make decisions based on what we know on the here and now. And so to me, based on what I know on the here and now, I choose to think that there is really a mind behind everything.
Could you talk a little bit more about the evidence for design? Because from my perspective, I don't understand why that there isn't any evidence for design. For me, it just seems like the naturalistic scientific approach is pushing forward. It's made some setbacks, hasn't really solved the problem yet, but I haven't seen any evidence, real evidence for design. I don't know what you mean by that exactly. What is that?
Yeah, well, okay, and again, the way I like to think about the evidence for design is in a watchmaker framework. And so I could give a lot of examples, but one example that I'll focus on here, to me, which I think is very impressive, is the recognition that the biochemical machinery that manipulates DNA during DNA replication or transcription or or during DNA repair is literally operating like a computer system. And what's going on are the enzymes that are manipulating the DNA in these different processes are analogous to the finite control that's part of a Turing machine, where the DNA, which is digital information, is the input and the output. And the theoretical foundation for how modern day computers operate was developed by Alan Turing, and he conceived of these entities called Turing machines, these abstract entities, where each finite control could do limited operations on the digital data going into the finite control, generating an output. And Turing reasoned that if you combined the output of one machine with the input, or made that the input of another machine, and strung these Turing machines together, you can do very complex computations in a machine context. And this is exactly what you see when you're looking at DNA, is that you're looking at essentially a collection of Turing machines that are manipulating digital information in DNA, where the DNA is the input and the output in each of these steps. And so and in fact, the similarity between DNA, between the operation of a computer and what's happening, you know, when DNA is metabolized, is so stark that it's given rise to a discipline in nanotechnology called DNA computing. Leonard Adleman is the father of DNA computers, where he's literally building computer systems using DNA and the enzymes that manipulate DNA inside the cell. And seems to be a very exciting, potentially very promising area in computer science and in nanotechnology. And so to me, this is a really powerful real life example of the watchmaker argument, where, you know, in Paley's day, a watch was arguably the pinnacle of engineering achievement. Today, computers are the pinnacle of our engineering achievement. And so, you know, we know that computers come from a mind, and we're seeing computer operations at the very heart of the cell's chemistry. And, you know, and they're so similar to one another that, again, it's spawning this discipline of DNA computing. So to me, that would be an example of a watchmaker argument that could be used to illustrate the design that you see inside the cell.
How is that fundamentally different from things like we see in physics, where hydrogen molecules come together to create stars, and then the stars compress the hydrogen molecules to create oxygen, and then they explode, and then separate all these heavier elements out into the universe, creating even more elements, which then bond into planets, which then the planets then separate the elements by using the separation of water, liquid gases, and solids. And then, like, for example, if it's in an ocean and the ocean has waves, then the waves can brush up certain minerals up on the sand, and then they can start to build minerals. So it seems like the same kind of complicated process of information can happen in purely natural things without any kind of a mind. Why are those two fundamentally different?
Yeah, well, I mean, to me, I wouldn't make the argument so much that it's the information content in this context that to me I think is impressive or is evidence for design, but rather what I would say it's the fact that the way that that information is being manipulated and processed is identical to how we would manipulate and process information in computer systems which we know are designed. And in fact, what you're looking at are real life examples of abstract machines. So the analogy isn't even between a machine that we would produce and what we see inside the cell, but rather it's between an abstract machine that is a theoretical construct and what we see going on inside the cell. And so to me, it's a watchmaker reasoning that's leading you to the conclusion. And Paley, William Paley is one of my intellectual heroes. I know that people tend to dismiss Paley today, but when he was laying out the foundation for his watchmaker argument, he was comparing a watch to a stone. Where he said, "Look, we can explain the stone, right? But the explanation for the stone isn't the same explanation that's required for a watch." And again, he laid out the fundamental difference between a watch and a stone. And likewise, I would say that if we kind of extend Paley's argument to what we're discussing here, I would say, yeah, we can explain stars in the same vein that we could explain the origin of a stone, but the explanation for a computer system is qualitatively a very different explanation than the explanation we would use to explain the formation of a star. And so it's not to say that there aren't processes in nature that can create, higher order structures or can create complexification. I fully agree that those processes exist and are, in many instances, are very well understood. But the nature of the complexity that we're seeing when it comes to DNA replication is qualitatively very different than the nature of complexity that we see, for example, when a star forms. What distinguishes it is that, one, in this case, DNA replication has those signature features that we would recognize as evidence for the work of a human designer, whereas the other doesn't display that signature.
Well, for me, my biggest problem with that argument is that the properties that you're describing seem to be imaginary to me. I don't think those properties actually exist. They're just things that we attribute, kind of like a bachelor. A bachelor isn't a function of the universe. It's just a thing that we define as being there because of our intuitions. So to me, the watchmaker analogy seems to have the same flaws, and I agree with like Percy Shelley's criticism that you can't infer design until you demonstrate the designer, or you need to find some empirical evidence that you can show that these features are in fact functions of designers and not just an imaginary property we're applying to things. And I don't see that empirical basis for that conclusion. They just seem to be imaginary properties that we're just assigning to me.
Yeah, well, and this is where this is where I think I would disagree with that critique, and maybe a way to help understand why I would disagree with it would be to think about the work in SETI, the Search for Extraterrestrial Intelligence. Because that whole enterprise is predicated on the idea that we can distinguish a design signature or the signature of intelligent agency, hence a design signature, and electromagnetic radiation emanating from a distant object. Sorry, losing track of my train of thought here. But in SETI, the idea is that if there's electromagnetic radiation emanating from a distant object, and we can distinguish between signatures for radiation emanating from natural objects or natural sources from those emanating from intelligent civilizations, where there's a design signature or a signature for an intelligent agency. And yet we could do that without having any knowledge of who or what that designer is. In fact, there's a paper, I couldn't pull the reference off the top of my head, I'm sorry, but it's from work by Harvard scientists from Harvard University that are speculating on the fact that maybe these short, what are they called, the fast radio bursts that people are detecting may actually reflect the activity of intelligent civilizations. They're arguing this might very well be a SETI type signal. And when they're arguing this, they're saying we don't know anything about the civilization, we don't know anything about their motivation, but yet we can still detect a design signature. And likewise, I would argue that when it comes to looking at a watch, even if I think that this is what Paley was trying to do, is he's saying even if we didn't know that there was a designer, a priori, we would conclude that this was designed because it has certain attributes that reflect what we'd expect a designer to do. And so that would really be what I'm trying to do is something I think akin to what SETI is doing. Is there are just certain properties here that seem to distinguish this system from other systems where we know that there are these mechanistic explanations for them. And they just happen to be, again, that design signature. So I don't think you need to know anything about the designer to infer design.
Well, SETI actually wrote a reply to creationists using that as an example for design, and they specifically said that they're looking for specific cases that we have seen because we know that there are certain properties of the designers, like humans. They're making an analogy to humans here and saying humans have these specific properties, and they then produce this specific thing due to these specific properties, and we're looking for that. So they're saying they're inferring from the properties of the designer what they can infer about the design. They're not just looking for design arbitrarily. So they are, in fact, going from the properties of the designer to the design, not the other way around. And that
Okay,
also seems to apply to things like archaeology and forensics and computer coding. It always starts from properties of the designer and then goes to the design.
Yeah, well, I'm not completely sure that I'm not completely sure that that's the case. So that would be a place where I think we would disagree. Another way to think about this is, in my book, The Cell's Design, and I'm not saying that other people that are making design arguments would be doing the same thing. What I do like about the watchmaker analogy is that you are using human designers again as the kind of the standard for what designers do. And so if you now put the watchmaker argument into the context of the Christian faith, or into the context of a Christian worldview, where you argue that designer is the creator described in the Bible, and you take the assumption that human beings are made in God's image, then what you could argue is that what we're doing as human designers reflects, in a sense, the imago Dei that's within us, and that there is somehow somehow what we're doing is essentially analogous to what the creator who made us in his image would do. And so in that case, you could argue that inferring that we could look for what human designers do, and that can then become a legitimate marker for design that we could then use to apply to a creator if we're assuming it's the God of the Bible and that humans are made in God's image. So that in my mind, that could be a workaround, though it requires, again, adopting a peculiar worldview to do that, right?
So have you read SETI's reply to the creationists using them?
I was not aware that they actually did that, so I would be interested in digging that out and taking a look at it. So I was just not aware of that.
I'll email it to you because I'd love to hear your thoughts on it.
Yeah. I'd
So,
like to take a look at it.
So, what was the last thing you said right before I mentioned that?
It was about the image of God.
Right. So there's a difference from what I can see. My perspective, what I consider to be evidence is there's several different kinds of evidence, and post hoc evidence of looking at something and then saying, well, we can define this or categorize this in a certain way doesn't really qualify as very strong evidence for me. For me, what qualifies as strong evidence is future evidence, saying if I have this theory, I can predict this thing in the future that no one knows yet, and we'll be able to discover it if my theory is correct. And so for evidence of design, what I would really like to see is if you can say, I have a theory of designer, here is how the designer did this, and we can replicate this in the lab, and we can be first to do it. That would be really strong evidence of design for me. But just looking at what we see now and then attributing properties to it is more post hoc, and that is not as strong evidence to me as something that's like future predictions, which evolution makes tons and tons of future predictions.
Yeah.
So would you agree that there's a difference between those two kinds of evidence, and that the future stuff is a lot stronger than the post hoc stuff?
Yeah, I don't think I would disagree with you know your categorization of different types of evidence and what constitutes stronger evidence. And one of the things that I am constantly doing is looking at how can we go about expanding the design argument. And one of the things that I'm beginning to explore is kind of inspired by work in biomimetics and bioinspiration. And one of the things that I think is really intriguing is that uh, engineers are now making kind of an industry of going to designs in biology and either copying them to solve engineering problems, or at least deriving inspiration and insight from biological systems and then applying them to you know to solve problems that they're having. And to me that's really provocative, because that I think might very well satisfy your criteria for evidence. Because to me the fact that we can systematically go to designs in, whether it's biology, or even we're seeing this in biochemistry with respect to the insights for nanotechnology, uh, is highlighting just how elegant those designs are. And of course, if you adopt a worldview or a perspective where there's a designer, a mind that's responsible, I think biomimetics and bioinspiration fit very comfortably within that framework. And I would argue that to me that biomimetics and bioinspiration fit awkwardly within an evolutionary framework. And the reason I would say this is because there are a lot of biologists that will make the point that biological systems are imperfect, they're inherently flawed systems. And it's because the nature of the evolutionary mechanism is, again, historically contingent, and that existing designs are co-opted, and they're modified and put together to generate new designs. And there may be some fine-tuning of those designs, but ultimately they're inherently cobbled together. And so if that's the mechanism for generating designs in biology, designs in biochemistry, you would think that those are designs that you wouldn't be really strongly motivated to study as a way to gain inspiration for new technology. So to me, I think the work that's happening in biomimetics and bioinspiration is opening up another type of design argument that I think complements the watchmaker argument and complements the argument from synthetic biology. And I think it's falling into the category that you're describing as being a stronger piece of design evidence.
Would that be fundamentally different from looking at like a wings of a bird and then trying to reverse engineer wings for a plane or something, or looking at the brain and trying to use neural networks in computer science, or looking at physical systems like fractal geometries of the way crystals forms and those things, and reverse engineering programs from looking at those physical systems? Aren't those all kind of the same thing? And would you think those would also be evidence of design?
Um, I mean, yeah, I think the first two examples you gave would fall into the category of biomimetics and bioinspiration. The last one, wouldn't be. But there, what you're doing is you're discovering mathematical principles. I think that exist in nature, and then using those principles to design things. So, that brings up the whole provocative idea that we can use mathematics, or that the universe is intelligible, right? That mathematics is eerie in the fact that it seems to be able to describe the universe.
The unreasonable effectiveness of mathematics.
Yeah, yeah. But so anyway.
So, do you think, like, why do you think this isn't vitiating the academic community? Like most world organizations seem to adopt the evolutionary and naturalist perspective simply because it is useful. They can make predictions about it anywhere in the world. They can always make successful predictions about it, but they don't seem to be able to do so with the creationist model, and that which makes it seem like it's only accepted by a certain subgroups in mostly the United States and certain Middle Eastern areas. Why do you think that is?
Well, to me, I think it has to do with the philosophical framework that undergirds contemporary science, which is methodological naturalism, right? And so within the framework of methodological naturalism, you can only pursue mechanistic natural process explanations for the universe and phenomena within the universe. And I think there's very good reasons for adopting that particular philosophical framework to do science. I'm not opposed fundamentally to methodological naturalism, but I think I would embrace more of what I would call a softer version of it than what what many in the scientific community would embrace, which I would say is a hard form of methodological naturalism. So I think it's a convenient way to proceed. But the bottom line is that within that framework, any kind of design explanation is immediately ruled out by definition, a priori, because it doesn't. You're evoking teleology, not mechanism, to explain the universe, and so therefore, evolution for chemical evolution for the origin of life, and then biological evolution for the design and the history of life is really the only option that you have. Now, what exact form or version of evolution is up for debate, but you have to have some kind of evolutionary framework. So it's not so much to me that a creation model or a design perspective are not scientifically or potentially scientifically productive. It's just that they're ruled out because of methodological naturalism. Now, I mean, to be fair, there are some forms of creationism that are, in my view, absurd, right? And and so many times I think when people think of ID or they think of creation, they think of really the most absurd expressions of these ideas. And so I don't criticize people for rejecting creation because of that, but there are versions of those ideas that I think really are scientifically rigorous expressions of those ideas that actually could function in principle, I think, as scientific models that would actually make predictions. And so, for example, one of the examples that ID people love to point to, that create people like me as an older creationist like to point to, would be the recognition that increasingly that junk DNA sequences have function. And in fact, when I started working at Reasons to Believe, this junk DNA argument, of course, was prevalent in terms of this is unassailable evidence for common descent. The shared junk DNA sequences that we see in organisms that naturally cluster together. And at that time, this would have been 1999. I in print made the prediction that one day we're going to discover function for junk DNA, and that conviction was based on the theory, the creation model framework that I espoused. And here we are, 20 years later, and we're seeing example after example of, junk DNA sequences having function. Now, I know that evolutionary biologists are arguing that, this idea of neo-functionalization, and that, this becomes the raw material for evolution to work with, and it converts the junk DNA sequences into function. So, you wouldn't necessarily say that the evolutionary framework wouldn't predict this, but you could actually point to the fact that this was a successful prediction of design. And in fact, a lot of the work that has gone into discovering function for junk DNA was really motivated not by a conviction that this is a prediction of the evolutionary framework, but it was accidental discoveries of function in non-coding or junk DNA regions through genome-wide association studies, where people trying to find the genetic basis for diseases. And time again, they were seeing that that association was happening in non-coding regions of the genome, and regions that we thought were vestigial junk of the evolutionary history. So this is an example where I think an intelligent design framework would have actually accelerated these discoveries as opposed to delayed those discoveries. And in fact, I've got an article on my website. The title's a bit kind of inflammatory, but it's called Evolution's Flawed Approach to Science. But what I do in that article is I just cite a number of studies that fall in that category where people saw structures in biological systems or aspects of those biological systems that just didn't make sense at the time of their discovery. And the conclusion was, well, these systems, because they don't make sense, must be just the byproduct of evolution. And then later on, we discover that these systems have function, not because we're pursuing what that function is. It's because it's an accidental discovery as people are working on other problems, and they just discover this from an accidental standpoint or serendipitous standpoint. And so to me, this is an example of where design could actually be very productive, from creation, from as a scientific program. And, I would argue that even in a sense, synthetic biology and biomimetics, which we've been talking about, really are, in a sense, intelligent design programs. That we're trying to design things based on what we know about the way nature works. And so I'm not completely convinced design is a non-productive scientific framework.
I would actually agree with you. When you were describing methodological naturalism, that sounds more like metaphysical naturalism to me, because I think there's a distinction between those two. And I adopt metaphysical or methodological naturalism just as the position that we have a method to determine natural things, not as the ruling out of the supernatural or of design. I grant that both of those are possibilities. I just don't think we have a method to distinguish them yet. And so I like to go with Robert Pinnock's definition and Lyle Shank's definition that methodological naturalism is just the usefulness of a method that we can use to determine natural things, as opposed to metaphysical naturalism, which is the rejection of the supernatural or the rejection of design. So would you agree that those are two separate things, and that methodological naturalism doesn't inherently reject the supernatural or design?
Oh yeah, of course, I would agree with that. So, and I appreciate your position on that. But in many respects, I think pragmatically there's no difference between those two forms and naturalism. That I think pragmatically methodological naturalism operates in the same way that philosophical naturalism operates. And I've heard other people refer to methodological naturalism as provisional atheism or benchtop atheism. And again, maybe that's an unfair characterization. And so I do recognize the difference, but I think in a practical sense, I don't know that. I mean, I would say that science is inherently atheistic, and I'm not saying that in a meaning anything derogatory or not trying to inflame by that statement. I think it is inherently an atheistic enterprise, and because of that, there's just not a place for design to enter in, and but I'm sympathetic to the concern that I'm sympathetic to the concern that people have of abandoning methodological naturalism as the framework for science, because it really disciplines the scientific investigator to ensure that they're pursuing explanations, that they're not just giving up at the first difficulty, or you want to make sure that you've got a framework that doesn't stultify science. Right. Although I don't think a design framework would inherently stultify science. I think there's a lot of motivations in that framework to pursue science just as aggressively.
Yeah, I'd actually be really happy if you could provide a methodological design or a methodological supernaturalism. And if it was as rigorous as the methodological naturalism, I'd be happy to adopt all three and use them at the appropriate intervals. So I don't think one rules out the other necessarily. But you also mentioned the junk DNA thing. From my understanding, the consensus is that about 10% of the genome is coding and the rest of it is non-coding. And the whole big debate about junk DNA and the functions just seems to be equivocation between different definitions of function, because there's like the biomedical definition of function, and then you have the evolutionary definition of function, and they seem to be, people are using the same word to mean multiple different things, but they all seem to agree that they're separate categories, and they agree that the evolutionary function is very limited at only 10%, whereas the the wider definitions of function can be applied to larger percents, but that was always predicted by evolution. They were just always using the more strict definition.
Yeah, I'm familiar. That's, great point that you're raising, and I'm familiar with those discussions. And I've written a series of articles on our website about the ENCODE project, which, when the phase 2 results were initially published, the claim was 80% of the genome is functional. And of course, they were using what Dan Grar calls the causal definition of function, which is the broader definition. And to me, I actually think that that's a more useful definition of function than the selected effect version of function. But what's interesting to me is that independent, and I know there's a huge debate over what is the percentage of functional DNA in the genome. And again, your point is really well made, that it depends on how you define function. And you can, I think, make legitimate arguments for both definitions. What is interesting to me is that there are other studies that are taking place that seem to independently affirm the conclusions of the ENCODE project, that a significant portion of the genome is actually functional. And I write about a number of those studies on our website for my blog, The Cell's Design. So, I think it's an outstanding question, but from my perspective, it really does look like a significant portion of the genome is functional if you adopt the causal definition.
Well, do you think that if we adopted the causal definition, that the scientists, like if the original scientists proposing junk DNA adopted the causal definition, that they would have made essentially the same prediction, that 80% of it was functioning by that definition? Like, it seems like the controversy is just that they didn't accept that definition when they defined junk DNA, but if they did, they'd make the exact same predictions that the creationists do.
It could be. I have not really thought about it in those terms. But but from my experience, working as a Christian apologist, again, that's using science as a way to defend the Christian faith. When I started working on this problem, there were quite a few apologists for the evolutionary framework that were more than happy to use the junk DNA argument, really emphasizing that a significant proportion of genomes were non-functional. And so, part of my response to that is also shaped by those interactions. So, and of course, I think somebody that works within science would be, justified in saying that really shouldn't bear on how we engage in this discussion. So I'm sympathetic to that point, but I do know that there were people that were very quick to use that argument, and, to undermine a creationist perspective. And so, anyway.
Yeah, well, thanks for coming on. I really enjoyed our conversation. I actually have to go pretty soon, but
Okay.
yeah, thanks again for coming on. Anything else you would like to talk about or mention at the end?
No, I enjoyed the conversation, and would love to be able to do something like this again. I appreciate the I enjoyed it. I appreciated the back and forth. Is this going to be recorded and then posted online, or just went live?
It went live, so it's already been broadcast. Yeah.
Okay.
But yeah, I'd love to talk with you and Hugh Ross again, because of the stuff you mentioned at the beginning about the origin of the universe. I'm also pretty familiar with that stuff, and I'd love to hear his thoughts on my rebuttals to that argument.
Yeah. Well, I don't know much about you. Could you tell me just a little bit about you, who you are, and your background?
So I wrote an epistemology and model of morality, and I created my YouTube channel as a means to promote it, because I use it to counter religious apologist arguments to show how effective my methodology is. And I'm trying to build up my popularity and publish this in a book. And I'd like to do this professionally and do like professional debates like Hitchens and Harris and Dawkins and those guys. This is a really awesome career. I love what you guys do. You have my dream job, just on the other side of the fence.
Yeah. Well, I appreciate that that we can have these discussions civilly. Sadly, that's not the case, and I can't think of a more important conversations to have than these types of conversations. And so I appreciate the the demeanor that you brought to this, and love to do it again. So
Absolutely, and I can't thank you enough for coming on, because this is the best way to learn, is to talk with people on the other side of the issue, because they've researched all the things you haven't, and they can point out all the weaknesses in your position that you've kind of overlooked. And so,
yeah.
thanks again. We really appreciate it.
Well, and same here. I appreciate your questions, and I'm looking forward to the email from you about the SETI rebuttal.
Absolutely, I will send that to you right now.
All right, thank you.
Yep.
All right, well, take care.
See you later.